Hello everyone, welcome to Unshackling Sudokus and Puzzles. Today I'll be talking through a crop key pairs clone Sudoku created by Priyam Bhushan. This Sudoku was created as part of a speed setting competition and it was created in just 30 minutes. So nowadays the trend seems to be such that authors are taking even lesser time than for the solvers to solve the Sudoku. So traditionally, it used to be in such a way that a solver is expected to take less time than what authors take to create the Sudoku. But nowadays, authors are just like that producing Sudokus. So that is interesting to know. If you want to try the Sudoku out yourself, the link to solve is given in the description of the video. You can try out the Sudoku yourself. It is an excellent one. I have tried it previously, and please do come back and watch the video. And if you haven't hit the subscribe button yet, please subscribe to the channel. We would really appreciate if you subscribe to the channel and support us. Now let us move on to the rules of the Sudoku. Classic rules apply. Each row, column and 3 by 3 box will have digits from 1 to 9 without any repetitions. Then crop key pairs rule apply, which means that if you have a black dot between two cells, those cells will be in the ratio of 1:2 or 2:1, right? And white dots will have consecutive digits and negative constraints do not apply, which means that if there is no dot between two cells, they can still have a difference of 1 or a ratio of 1:2. And the last part is the clone part. So this green shaded region will exactly correspond to the green shaded region without any rotation or reflection, which means that if you take this cell row 1 column 1, it will be exactly same as row 7 column 7. And similarly this pink color shape will also be equal to this pink shape. There will be exact correspondence. So these are the rules. With that, we'll start solving the Sudoku. So the first thing to see is that when you have a sequence of two consecutive dots, then it means that there is only one possibility. You either have 1, 2, 4, but we don't know the order yet, or the other possibility is 2, 4, 8. In both the cases, we are sure that 2 and 4 must be let me use a corner pencil mark. 2 and 4 must be in these three cells. That is for sure when you have two consecutive black dots. The next thing to see is that we have a dot in row 1 column 1 and row 2 column 1, which means these two are in the ratio of 1:2. Also a dot between row 2 column 2 and row 3 column 2, which means these are in the ratio of 1:2. And since they are clone shapes, which means that row 7 column 7 and row 8 column 7 and row 8 column 8 and row 9 column 8. Did I get that right? I think so. So these two cells, pairs of cells, are also in the ratio of 1:2, which means that we have a sequence of 4 cells which are in the ratio of 1:2, and the only possibility is either this 1, 2, 4, 8 or going the other way 1, 2, 4 and 8, right? Which means that since this is a clone, so you'll have the exact same cell. So that's a 2, 4 pair and that's 1, 8 and that's 1, 8, right? So since you have a black dot here as well, that black dot can be reproduced here and we get a sequence of 4 digits which are in the ratio of 1:2. So this is the only possible combination. And so you have a 2, 4 pair here, which means that this cell cannot be a 2, 4. So this is 2, 4 and that gives you an 8. Or if you have a 4 here, this becomes 2 and this becomes a 1. So these are the only possibilities here. And now you can look at this black dot. So if I have a 3 or a 6 here, so when you have a black dot, there are exactly 4 different possibilities, either 1, 2, 2, 4, 4, 8 or 3, 6. So if I have a 3, 6 here, what happens is that there is simply no way to satisfy these cells, right? Actually there is a way, but that breaks this box eventually. So if I have a 3, 6 here, I have a sequence of 3 consecutive digits here, which means that you have 3, 6 and the only possibility is to have an 8 here and a 7, 9 pair here. But now what happens is that when you look at this box, look at these two cells. You can't have 1, 2, 4, 8 and you also cannot have 3, 6, 7, 8, 9, which means that we are breaking the Sudoku here. So there is no possibility to have 3, 6 here. So it's either 1 and 2. So in which case I'll have 1, 2 here. or 2 4. 2 4 is ruled out because you have a 2 4 pair, or 4 8. So 4 and 8. So these are the only possibilities in these two cells. So which means that this cell now becomes 1 or 4. So if this is a 2, oops, I have written wrong pencil now, guys. So if it's 1 and 2, it would be 2, this would be 1. And if it's 4 and 8, this would be 4 and this would be 8, which means that this has to be 2 and 4, right? So it's this two cells are either 1 and 2 or 4 and 8, only two possibilities. So the next thing is we can look at this cell, row 3, column 6 maybe, because it is heavily constrained. It is sharing a cell which has a black dot. It is also sharing a cell which has a white dot. So we can try to use that to our advantage. So if this cell cannot be 5, 7 or 9 because they cannot be a part of a black dot. So the remaining digits are 1, 2, 3, 4, 6, 8. But you also cannot have 1 because 1 would require a 2 here and 2 is not possible. So now the remaining possibilities must be 2, 3, 4, 6 and 8. No other digit is possible. So if I have a 2 in this cell, I can't have 4 here, so this would be 1 because this can only be 1 or 4. But again, I will require a 2 here because of the white dot. So 2 is also removed. Can I have a 3? 3 gives me a 6 here and a 5 and 7 here, which is possible. And can I have a 4? 4 gives me an 8 here and a 7 or 9 here, that is also possible. And if I have a 6 here, again 3, but 3 would require 2 or 4 here, but you can't have 2 or 4, so which means that 6 is also removed. And 8 requires a 4 here, right? But you have a 2 4 pair, so 8 is also removed. Awesome. So this cell is very, very powerful, guys. So you'll have only 3 or 4 here, which means I can reproduce that here. So this would be 3 or 4, which means if this is 3, this has to be 2 or 4, and if that's 4, this has to be 3 or 5, so that's a 3. So you can't have a 5 here in a black dot, so this cell can only be 2, 3 or 4, right? And now is the time for the break-in in the Sudoku, guys. Not really easy to spot, a very difficult one. So the way I found out is that, so I use some coloring here, maybe 2 colors which are distinguishable. I'll use an yellow here, and for this I'll use blue maybe. Okay, so if this is an yellow cell, I'm going to use yellow and blue to disambiguate 2 and 4, right? If this is an yellow cell, this becomes a blue cell, so that would be yellow again. So you'll understand why I'm doing this. So this would be a blue, this would be yellow, and because both of these are clones, so this would be yellow, and okay, and because these two shapes are clones, so that becomes yellow and that becomes blue, right? Now the question to ask here is, at this point the Sudoku is really difficult to continue, guys. So maybe I'll write some pencil marks here. If that's a 3, it's a 6, and if it's a 4, it's an 8, right? And which means these digits will be 5, 7, 9. Okay, so at this point the question to ask is, can you have a 2 or a 4 here? And what happens if you have a 2 or a 4 there? The answer is you can't have a 2 or a 4. So let's see. I don't think there is any other way to break in the Sudoku, because I was trying not to use this idea at all, but I just could not find out anything. So if you have a 2 or a 4 here, this obviously becomes an yellow cell. Now both of these cells are equal. So let's say you have a 2 here, right? Oops. Let's say you have a 2 here, which means that this becomes 4 and 8, right? Because we know that this would be 1, 2, 4, 8 or 1, 2, 4, 8. So if that's 4 and 8, this has to be 2 and 1. And now look what this becomes. We know that this is either 1 and 2 or 4 and 8. We saw that earlier because of this 2, 4 pair. So the only two possible pairs here are 1 and 2 or 4 and 8, nothing else. 2 and 4 is not possible. So if I have a 2 here and a 1 here, yellow cells would be equal. So that's a 2, and this also becomes 1. So you have a clash here, not possible. Now let us see with a 4. Suppose if you have a 4 here, if that's a 4, that becomes 2 and that becomes 1. And now the only possibility for the 4 is 8. And now we know that these two shapes are equal, I mean they are yellow. So which means that this would be 4 and this has to take an 8 again. So again we have a clash of digits, which means that the answer to our earlier question whether this can be 2 or 4 is no. So that is the most difficult thing or the break-in to spot in the Sudoku, guys. So which means that this cell has to be a 3. And now you see how the Sudoku is progressing. I was really impressed with this construction. And to think that this was created within 30 minutes is just simply mind-boggling. So we have a 3, 6 here. And that becomes 4. Which means that these two cells will be 4 and 2. So I'll remove the yellow cells. And I'll also remove the highlighting now. They have served our purpose. So all these cells can be removed of their colors. So which means that this would be 1 and 8, right? That has to be 1, that has to be 8. And I can reproduce this entire clone here. So that would be 8, 4, 2 and 1. And this becomes 2 now, which means this would be 2 now, and that has to be a 1. And this has a consecutive digits which is 1 or 3. That is a 1 here, so that has to be a 3. That becomes 4, that becomes 2, and that has to be a 1. And you have a 4 here, I can reproduce that here, so that's a 4, which means that would be 8, and that has to be 7 and 9. Awesome, guys, awesome. Look how just this one break-in has given about 15 or so digits. Awesome, right? And now you can just simply try to use some classic and continue the Sudoku. So I have a 1-2 pair here and a 1-2 pair here, which means that in row 1 and 2 must go into these cells, these 3 cells, right? And I can remove the 2 from here. If this is a 2, 1 goes inside and you will require again a 2. So this is not a 2, so that's just 1. And I have a 2 here, I have a 2 here and 2 in row 4. So 2 is placed due to classic and 1 is again placed due to classic, which means that these 3 cells must now be 5, 7, 9 for the column. And reproducing that cell here, so that becomes 5, 7, 9. And I have a 6 in row 7, which means 6 must be in one of these cells. And that gives 6 in one of these cells. There is also 3 in column 8, so which means that 3 must be in these 3 cells. Which means 3 must be in these 3 cells. But this can't be a 3 because you will require a 2 or 4 here. So that is removed of a 3. And correspondingly these 2 cells, one of these 2 or 3. There is a 8 in row 1, row 2, so 8 goes in one of these cells. And can I have an 8 here? I think so, there is no issue there. So 8 can be here, but 8 can't be here, right? So this is not 8, which means that this has to be my 8. Because if this cell is 8, you have again an 8 here, so that's not possible. I can place the 4 using classic, which means 4 must be in one of these 2 cells. And this cell can't be 1, 2, 4, 8 and 3 and 6. So this is 5, 7, 9. And which means correspondingly that is also a 5, 7 and 9. So if you look closely in row 3, you can't have 3 in white dot cells because you have 2, 4 outside, and you also can't have 3 here because there is a 3 here. So these 2 shapes are clones, which means that there is only one cell for the 3 in row 3. So that would have to be a 3 now. The moment I do this, I can't have I have 2 inside this white dot, which means that 2 would have to go with the 1. So this becomes a 1-2 pair because 2 will have either 1 or 3. 3 is ruled out, so that becomes 1-2 pair. And now I have removed 2 possibilities from the black dot. 1 and 2 is ruled out, 3 and 6 is ruled out, which means that these 2 cells must either be 4 and 2 or it is either 4 and 8, right? Only possibilities now. So which means that this cell is a 4 no matter what. So that becomes 4. And using classic I can place again a 4 in box 7 and again a 4 in box 8. So I have placed all the 4s in the grid. So 8 is not possible here and 8 is not possible here. So one of these cells is an 8. And 3 is not possible here. And one of these 3 cells become an 8. But you have a 3 in row 4, which means that this cell is not an 8. And that locks us a pair in 3, 8 in box 7. That becomes a 3, 8 pair, which means that this would be 5, 7, 9, right? And correspondingly this would be 5, 7, 9. So let us look at this cell. So this is 5, 6, 7 or 9. But if you look carefully in column 3, these 3 white dots now, because of the presence of 1, 2, 4 here, will have to take a 7, right? Because if 7 is not here, let's say you put a 7 somewhere outside these 3 dots, there is no way possible to make 3 consecutive digits. Simply not possible. So which means that 7 must be in these 3 dots. So this cell is not a 7, which means that this cell is not a 7. So that's 5, 6, 9. And you have 2 consecutive digits in that row and 8 outside. So which means that 9 cannot be here, which means that these 2 cells must be a 5, 6 and a 7. There was a corner pencil mark of 6 here, right? Let me put that. And 6 must be in one of these cells, because without a 6 this becomes 5, 7 and there is no way to be for it to be consecutive. So 6 must be in one of these cells, which means that this is not a 6, and which means that this must be a 5 or a 9. Awesome guys, really nice Sudoku. So again, really tough deduction to see. If you have a 5 here, this becomes immediately 6. But if you remember, we had made a pencil mark of 6 in these 2 cells and these 2 cells earlier. So if this is a 5, this would have to be 4 or 6. But 6 gets pushed here and both 4 and 6 are rolled out. So this is not a 5. So if that's a 6, it can't be 6, 5, 4. So this would be 6, 7, 8. And if that's a 7, it can be 6, 5 or 8 and 9, right? Both are possible. So let me write that 6, 5 or 8, 9. So these are the exhaustive list of possibilities that can go in this Sudoku. Go in these 3 cells. So again we have a really narrow deduction, you can say. So suppose if you have 7 in this cell, 7 in row 7 column 2, this also becomes 7, which means that in box 4 now you don't have any cell left to take the 7, which means that I can remove the 7 from that cell. 7 is not possible here and here, as both are clones. So this becomes 5, 9 and this becomes 5 and 9. And let me use some classic here. So one is in row 8 and 9, so one is in one of these 2 cells and one is in one of these 2 cells for column 7. And 3 goes in these 2 cells. Okay, this is nice guys. So if I look a little bit closely at column 3, you'll notice that 8 cannot go in these cells. So 8 must be in one of these 2 cells, right? Which means that our possibility gets reduced further. So if I have a 5 here, that becomes 8 and these 2 cells will lead to a clash. So that's not a 5, that is 8 or 9. So which means that I can reduce the possibility here too. So this cannot be a 6, because if that's a 6, there is no way for these to be consecutive. So that would be not a 6. So that becomes 7 and 8. So a small thing to observe here is one of these 2 cells will take a 7 and one of these 2 cells would have to take an 8. Okay. Again, you can say a razor sharp deduction guys. It all revolves around this clone and column 3. So let's say you have a 5 here. Now the only place for 5 to go in box 4 is again here, which means that these 2 shapes, the clone shapes will also take these 2 5s. And when you have this scenario, there is no space left for the 5 in box 1. A really tough deduction to see, but really nice to see as well. So 5 has no space left in box 1 now, which means that you can't have a 5 here. So I think this should be the final nail in the coffin of the Sudoku. So this has to be a 9. That becomes a 9 correspondingly, and which means that becomes a 5-7 pair. And notice that immediately we can't write a 9 here. Earlier when we had a 5 here, there was only one cell left for the 5, but the 9 could go here as well, so we should not immediately write it. There are 2 cells left for the 9. So which means this cell is not a 9. Actually, you can still eliminate the 9 from here, because if I have a 9 here, that becomes my 9. Again we have the same situation, and there is no space for the 9 in box 1, so this is not a 9, right? So that's a 5, which means that's a 5, and that's not a 5, so I have a 6 7 pair now, and that gives my 9 here, and which means I'm going to complete soon, I guess. So this would be a 9, that's not 9, and this would be a 6 and a 7. So 1 2 3 4 5 and 9 goes in exactly this cell in box 4, so that's 9, which means that's 8, that's 7, that's 6, that becomes 5, and these two cells now become 3 and 6. And notice that these two cells do not have a dot, and as per rules negative constraints do not apply, so it's perfectly fine to have a 3 6 pair here, which means I can correspond this shape with the same digits. That would be 5, that would be 7, and which means 7 5 pair gets resolved, so this would be 5 7, and these two cells must be 6 7. And for row 4 I can put some digits. These would be 5 6 7. You have a 6 here, so that's not a 6, so that's 5 7. And if I look at column 9 now, 1 2 4 3 6 7, there are many places to continue. I'm just looking at column 9 because I'm seeing a digit here. 1 2 4 3 6 and 7. So this cell can be 5 8 or 9, but both 5 and 8 are ruled out, so that's a 9. And these two cells become 5 8, which can be resolved immediately, so that's a 5 and that's an 8. 2 3 4 5 and 8, so 1 6 7 and 9. So 9 has only one cell left, can't be, oh sorry, can't be here and can't be here, so that would be a 9. And okay, so that's 6 and 7, and that would be 6 and 7 for the column 8. 1 4 9 2 5 8, so this would be 3 6 and 7. Okay, so the 5 has only one cell left in row 2. You can place the 5 here, and that immediately gives a 7 here. That gives my 7 6 here and a 5 here. Okay, 2 4 6 9 5 and 8, which means this pair can be resolved, so that's 6, that's 3, which means that this can be 3 6, and that gives 7 here, a 6 here and a 3 here, and which means that's a 9. That has to be my 7 for the row. That gives 6 here, 2 3 6 9 4 5 8, so these two would be 1 7. You have a 7 here, so that's 7 and that's 1, right? So awesome guys, such a clean construction. So that would be a 6 now because of the 8, and these two are consecutive, so this becomes 2, that becomes 1, because you have 2 8 here and 8 is here, so which means these two cells must be 3 and 8, and that can be resolved. That's 8, that's 3, and 1 2 can be resolved. 2 5 6 7 1 4 8, these two would be 3 and a 9, so 9 is here, which means that's a 9 and that's a 3, that's a 3 and that's an 8. 1 3 7 9 2 4 6, so that's an 8, that's a 5. 3 4 5 8 2 6 9, so that's 1, that's 7 and 6 and 2. With that we have completed this really gorgeous construction by Priyam Bhushan. She should be really proud of this construction, and to produce this Sudoku within 30 minutes is such an awesome feat, guys. Really enjoyable Sudoku. So if you guys had any queries regarding the Sudoku, please post in the comments of the video, and if you found any other break-in at the start, we would really be happy to know, and we'll happy to acknowledge that break-in. So do remember to subscribe to the channel. We hope to see you soon again with a video. Take care guys, bye bye.